Hello everyone, welcome back to our channel. Today we are back with one more important problem, linked list problem. That is, the name of the problem is reorder list. It is there on the blind 75 SD sheet and you all can refer from the problem from lead code as well. So let's see the problem statement. So we have been given the head of a singly linked list and the list can be represented as like L0, L1 and ln-1 ln. So what we need to do is basically in this pattern we will be getting the list and we have to reorder the list to be on the following form. That is L0 ln L1 ln-1 L2 ln-2. So if we carefully observe basically what it is happening, the pattern, if we can decode the pattern, that is very simple. So what we are doing is, after reordering, what we are doing is basically we are taking the first element, then the last element, then the second element, then second last element, then third element, and after that third last element. So every alternate element is similar. Like if you see, this was the original list, and alternate element if we see L0, L1, L2, like that. Okay. So here one more condition is given. We may not modify the values in the list nodes, only nodes themselves may be changed. So basically it is saying that we can't directly modify the value of the nodes. Basically if we do so, then the problem will be very simple. So we are restricted to do so. Okay. So let's see through the example. Like we are having example like 1, 2, 3, 4. And if we want to reorder it in this pattern, so we need to take first element, then we need to take last element, that is 4. Then we need to take second element, then second last element 3. Okay. Let's see one more example to be on a more clear phase of the problem. So the example is 1, 2, 3, 4, 5. And so we will be doing similar, like first element, then last element 5, and second element 2, second last element is 4, and after that the third last element or the third element, that is 3. So we can see like the pattern is being followed, and we are also having some constraint which I'm going to tell them, like the number of nodes is between 1 to 5 into 10 to the power 4, and each node's value is between 1 to 1000. And at last, like as I already told, only nodes themselves may be changed, like modifying the values directly is not allowed. Okay. So the nice solution for these type of question, what we can do if we tackle this question randomly. So like what we can do is basically we will try to copy the data of the linked list and convert it into array. Similarly, like copy the linked list to an array. And for why we did so, because to make the operations easier. It's obvious that we also know the operations on array are much easier than on linked list. So basically what we will do, we will copy the linked list to an array and we will traverse the linked list and store the nodes in an array for easy access. Okay. After that, what we need to do is basically we need to reorder using the 2 pointers. Okay. We will use 2 pointers. One will be starting from the beginning and other one will be starting from the end. And what we can do is basically alternate between both pointers to build the new order. That is the new pattern we have to do. Okay. After that, we need to reconnect the nodes. And at last we will iterate through the array and reconnect the nodes to achieve the desired sequence. But as we saw, there are a lot of steps, and here if we see, like time complexity will be for traversing the linked list once and iterating through the array will be like O of n twice. Okay, O of 2n. And then space complexity is also used also more, that is we are using extra space like for copying the element node data into an array from linked list to an array. So O of n will be for the extra space. But what if we try to do like optimized approach for this type of question? Basically how we can approach it, this was the solution is basically in one go we have to tell to the interviewer like what we are trying to think, but he or she will definitely say that to optimize the solution, to think differently, to think much more better approach. So what we will do is basically, I will tell you, like optimal approach for this problem is basically using the two pointer. We are using a two pointer here, as we are using the two pointer approach in brute force also, but we were using it differently. Here we are using it basically with different method, like two pointer plus reverse plus merge technique. Okay, so I have break down the step. I have broke down the complete approach into the 3 steps. So it will be easier for you all to get it. So step 1 is basically we will find the middle of the linked list using slow and fast pointers. Okay, and we will use the slow and fast pointer technique to locate the middle node efficiently. Basically, this can be done with the tortoise hare approach, as I discussed in previous linked list videos as well. Okay, in step 2, what we need to do is basically we need to reverse the second half. Okay, that means after getting the middle, we need to reverse the second half. After that, we will reverse the list starting from the middle to the end. That is step 2. After doing this, we have to move towards step 3, that is the merge the two halves. That is alternates nodes from the first half and second half to achieve the desired order. So it is basically common sense technique, like what we can do to make our linked list in that order. So this is the alternative, like good technique, good way to solve this problem. So I will tell you a dry run for doing this. Let's go through a detailed dry run step by step. So dry run, we are doing it for the input. We are having 1 2 3 4 5. Suppose the list is 1 2 3 4 5. So the first step is finding the middle of the linked list. We will use slow and fast pointers to locate the middle. Okay, currently slow is pointing to head, that is 1, and fast is also pointing to 1. Okay, but slow pointer moves one step ahead at a time, and fast pointer will be moving two nodes ahead at a time. Okay, but initially both are at same position. So iteration, these are the iterations, and these are the slow positions and fast positions. So first iteration is basically after first iteration, like slow will be at 2, but fast will be at 3, because it is fast will be moving 2 positions ahead at a time, and slow will be moving like 1 position at a time. So slow both were at 1, then slow will be at 2 at first iteration, and since fast pointer was moving 2 positions ahead, like after 1 it will be at 3. So that is the case here, we can see. And at second iteration, like slow will be one more step ahead, that is 3 at 3, but since fast was already on 3, so it will jump to 5, that is 2 steps at a time. So at this time, at third iteration, slow will be at 3 and fast is pointing to null pointer. That means it is the indication basically that it is the end of list. That means the slow will be pointing at the middle, and we got the middle, that is at node 3. At this point, list 1, that is first half, is basically 1 2 3, and list 2, that is the second half, is basically 4 5. So step 2, now we have to implement, like we have to reverse the second half. So 4 5 will become 5 4. Basically we now reverse the second half. Original second half was 4 5. After reversing it, basically it will become 5 4, right? So what we did was basically iteration, current, and next, and modified list. Basically at first iteration, current is at 4, next was at 5, and modify we have to do. Basically how we will do, we have to point the after 4 we have to point after fourth node we have to point it to the null pointer to make it the last node, to make the 4 as last node. And current and in second iteration, we need to, if current is equals to 5, we need to point like next is equals to null pointer, and 5 after, basically we need to point 5's next as 4 and 4's next as null pointer to make it into reverse. You guys will get it basically if you see the video of reversing the linked list. Basically this particular task you can get it that from here, but here also it is quite clear what I am trying to tell. Suppose at 4, if we want to reverse it, so 4 will be at last, so 4's next will be null pointer, and 5's next will be 4. So that we have to change the we have to change the nodes, the point where they are pointing. Okay, So at step 3, this is the last step, we need to merge the two halves. So we now merge the two halves in the required order. That was the 1 2 3, and reverse second half will be 1 2 3 5 4. So merging process is quite simple. Like if we see step first pointer, second pointer, and modified list. So if we start from first is equals to 1, second is equals to 5, that is first and second. Okay, if we see we are placing two pointers here, and second is equals to 5, modified list will be 1 5, and at next step first will be 2, that is one step ahead, and second will be at 4, basically one step ahead, that is the, so we can say that the modified list will be 1 5 then 2 4. Okay, then final step is like first in first half the first will be 3, and the second half it will be like null pointer because nothing is there after 4. So we can say that 1 5 2 4 3 will be the modified list, and the final reordered list will be 1 5 2 4 3. So this is quite very good approach. Time complexity for this approach will be often, and in space we didn't use any extra space. That was the basically reduction. Basically in brute force we used an array. Okay, but here it is we didn't used anything extra. Okay, so if we see if you guys wanted to know the detailed time complexity and space complexity analysis, basically finding the middle or that will be in O of 1, basically only pointers like slow and fast are used, nothing extra. And after reverse, basically for reversing the second half it will be O of 1. Okay, and merging the two half will be also constant, taking a constant space, and since all the operations are performed in place, the space complexity is constant. Okay, now let's see the code. Okay, basically this was the problem, and first of all this was the function declaration. This was the definition of singly linked list. Okay, so basically we first of all we need to tackle the edge cases. If the list has fewer than 3 nodes, no reordering is needed. Okay, basically if the list is less than 3 nodes here, so we don't need to reorder it. So basically this is the condition here, you can see. After that, finding the middle, basically we will here, this part is basically tortoise hare approach. Basically you can it related with the, if we see the problem finding the middle of a linked list, this is basically that only, nothing anything special. List node slow is equals to head, and the fast is also head, and this is basically slow will be moving one step ahead at a time, fast will be moving 2 steps ahead at a time. So that is quite simple. And in this also, basically this part is basically reversing the linked list code. If you can relate it with that, it is quite similar with that. So reversing the, here we have to not reverse the complete list, but the second half of the list we have to reverse. So we are taking it using previous like node, that is null pointer, we have to point it, and current is equals to slows next, and slows next will point to null pointer. Okay, as I discussed in the try run as well. So this is quite simple. Okay, then we are using a loop here for storing the next node, and reverse the, we have to reverse the link also. For reversing it, basically we have to move the previous forward, and we have to move current forward. Okay, after that we come to the step 3, that is the merging the two halves. Basically list node first is equals to head, and list node second is equals to previous. Basically these are two like pointer to the first half, and this is the pointer to the reverse second half. Okay, so here we are doing what we are doing, we are basically storing the next nodes by using the while loop. This was quite simple, reordering links as I told you, like from the first half and the second half. At last we have to move pointers forward, that is the first is equals to temp1, second is equals to temp2. And if we submitted this code, we can see it will pass. Yeah, it will pass. Okay, so I hope I was able to clear you the approach, and if you guys understood the solution, please do hit the like button and subscribe to the channel, and please share it to the other student as well. Thank you.